tested the video? Yeah. Thanks for coming to this. This is Jonathan Foote. You're an engineer, and he's going to be talking about sensors, all kinds of sensors, some of which you're carrying around right now, maybe not even wittingly, but it's sensors everywhere.
Thank you, Bernie. I'm always a little surprised when a talk of mine actually gets accepted because I'm not sure it's actually as interesting to anybody else as it is to me. It certainly seems less important than a lot of stuff is going on, but thank you for coming, and I'm going to try and make this as quick, as informative as possible. Before I start, a big thanks to everybody at Hope for doing all the stuff they do. Someone had to hang those lights. You know, the sound in the back of the room, it is ace, right? So thank you to the Hope people. Yeah, thank you to all the AV and everybody behind the scenes that we don't even know because they're doing their job so well we're not even noticing it. So thank you, everybody. When I was preparing this talk, a minute after I submitted it, I realized there's a better name for this talk, which is sensor overload, because I have way too many sensors to talk about. They're all fun, they're all cool, and some cool stuff you can do with them. So this is kind of fire hose, so I'm going to go pretty quickly. There's no real good way to arrange all this material. There's no good skewer through the shish kebab, so I've kind of arranged it like this. It's not actually a 3-day talk, although I could talk for 3 days. We're going to start kind of with photosensors, just stuff you can do optically. We're going to do chips and MEMS, and then there are all kinds of other crazy stuff, and then finally we get back to optical stuff again. So a little bit about me. Credentials don't matter. I'm a tinkerer, I'm a hacker. I do robots for fun, and I do robots for a living. I like making art robots. I like making cocktail robots. These things here that you're seeing are not actually cocktail robots. These are surgical robots. These are prototypes of a system that uses a high-pressure water jet to remove tissue. And this is probably the most terrifying day of my life where they're using my janky code on a real human being. All right, I need to reassure you that once we got funding for this company, it's called Procept Biorobotics, they hired the grown-ups and the people who knew what they were doing, so there's no chance of my janky code getting anywhere near your tender bits. So relax your mind and let's float downstream on the fire hose. Okay, I'm going to talk, as I said, about the first part is going to be optical sensors. Now, everybody has seen these or used these, and they turn out to be kind of everywhere. That first thing at the top there, that's you just have a LED which shines on the photodiode. The photodiode looks like a switch. When the light hits it, it turns on. This is easy to interface to a microcontroller, to an Arduino. It needs a couple resistors, but a bunch of how-tos. You see this everywhere. That kind of interrupter thing, there's one in your printer that tells you when it's out of paper. This thing in the middle there's one in the bathroom which flushes the toilet when you stand up, or it's supposed to do that, right? Sometimes it doesn't. So this kind of thing where you have this, either this interrupted thing where you have a beam of light which is blocked, or you bounce a beam of light off something else, you pick it up. Very common design pattern, we'll see it a lot. Here's something I did with this kind of retroreflective thing. There's a whole bunch of sensors arranged in a sphere that you can do cool things with. This is a recent interest. This is called PPG. Let me see if I can not mess this up, which is a photoplethysmograph, which basically measures your heartbeat by detecting when your heart pumps blood through your finger or another part of your extremity. It absorbs more or less light, and you can detect that with an optical sensor. There's this transmissive thing, goes right through your finger, and there's also a reflective thing. This is what on your Fitbit, what's on your Apple Watch. This is kind of hard to do because the actual change is very, very small, and so you need to do a little bit of finesse to actually pick up that signal, but you can do it. Here is something that you can buy. It's not very expensive if you want to experiment with this stuff yourself. I got one of these because I'm doing an art project using this to make stuff beat in time with your heart. I also got this, which is super cool. This is a pulse oximeter. This measures how much oxygen is in your blood as well as your pulse in real time, and it has streaming data. This was very inexpensive. My doctor wanted $400 for something like this for one night, and you can buy this for $30 and wear it for a week and get used to it. software it came with was not great, so I cracked it. I didn't crack it, I just man in the middle. The serial protocol wasn't hard. If you want to do this, it's online on my GitHub. Let's see, what is next? Optical encoders. These are super fun. They're everywhere. Every robot arm that has a joint has to know where it is, what angle it is at. And this is quite often how they do it, using these optical encoders. And these are very easy to interface to a microcontroller. You have two of these interrupter things, and they're interrupted by this slotted disk you can see in that middle picture there. When they turn in one direction, they're in one phase, and when you turn in the other direction, it's the other phase. So typically what you do is you put one of the signals to trigger the interrupt, and when in the interrupt, you look at the phase of the other signals. If it's high, you increment a counter. If it's low, you decrement the counter. Super easy, really works. But these don't tell you where you are. They only tell you how far you've turned since the last time you knew where you were. And we'll talk about that later. But here's a project that I did. Actually, my friend Charlie made this giant thing using hydraulics, and we didn't want to crush any Coachella bros, so we made a 12, this thing is giant and it moves with hydraulics. There's 12 different joints on them, and did a little feedback thing with that optical encoder to tell you how far that was over and whether to turn on or turn off that hydraulic valve to move it to the place it should be. Okay, this is something a little fun. This is a distance sensor that uses optical thing. It basically bounces off something in front of it and measures kind of the angle. I'm not actually quite sure how these work. I think there's a little microprism array in there. One of these days I'll take one apart and figure it out. But these are not expensive. These are fun. I can imagine all kinds of uses for these. Maybe someone will put one on a conference badge and measure how far the person is in front of you. You might have to discount for the reflectivity of black t-shirts, but maybe light up a little LED depending on how close they are to your personal space, and you can kind of dial that in. I don't know. All kinds of fun stuff you can do. Sometimes you don't need a camera to pick up light. This is kind of a 1 pixel camera. This color sensor, shout out to Adafruit for open source hardware and making this really easy to use. And there's code on the Adafruit website for using these sensors. This is a 1 pixel camera. It has 16-bit color resolution, red, green, blue, and all bandwidth. You'll notice on the right there, that thing that says SCL and SCA, that is a very standard serial protocol called I2C. It makes it really easy to use. Quite often somebody has a library for interfacing. In this picture on the lower right there, that's Arduino, and you see the SDA and the SCL serial data and serial clock. All you have to do is hook those up and make sure you're on a common ground, and things will usually work the first time. It's kind of amazing. And almost all these sensors that I'm presenting, somebody has already written a driver. You basically talk to them by writing registers, and somebody's figured all that out, or it's not too hard to do that by reading the data sheet. All this stuff is pretty easy to use, surprisingly easy. Okay, here's an application of a color sensor that I think is super great. This was a interactive installation done by Micah Scott, Scanlime. That thing on the right there, that's a giant interactive wall, and those things are knobs. You turn them, those circular discs. So she needed a lot of position sensors to detect what angle that these things were at. And so she did this ingenious hack with a color sensor. She printed out these colored sheets behind these things, and they're big, and then so depending on what color the color sensor sensed, you could tell what angles these were. They didn't need to be very precise, but this looked very robust, and this is a really nice hack, so I love this. See, what else? Cameras. Cameras a whole talk in themselves. Just a couple things I wanted to point out. Raspberry Pi and PiCam, there's this thing called Motion OS, which lets you do a streaming camera if you want one for your doorbell or your laundry room or something, and you don't want to be part of a botnet, or at least less likely to be part of a botnet. You can roll your own, and that's super cool. OpenCV, computer vision library, very powerful. People have been working on that for 20 years, does really amazing stuff. YOLO is a neural network recognition library. I haven't used it myself, but the demos look really awesome. This thing works at 30 frames per second, and it can detect things like bicycles, a car, or that funny shaped cat there in that picture there. There's also other things, cameras that use structured light to detect depth, and that's like the Real Sense and the Kinect. That's a little bit out of scope of this talk, but I thought I'd mention them anyway. Moving on, OpenMV camera. This is a camera with a super powerful ARM processor that's doing some image processing right on the board. You can take this and hook it up to an Arduino. There are people doing DIY robocars who are racing around, I think this one won the last one. They're basically following a racetrack autonomously, and they race these things in Oakland pretty much every month, and they're doing pretty well just using hardware like this. If you want your own forward-looking infrared camera, you can make one using the lepton sensors. I think all this stuff is kind of encumbered by patents and military ITAR restrictions, so it's kind of great that you can do this stuff yourself. It seems like this might be the killer app for autonomous vehicles because they can see pedestrians at night, which is a handy thing to do, but there is some restrictions on that. I don't know the full details of that, but it seems like a natural solution. You can also do detect UV. The one on the right, people put them on wearables to detect on how much sun you're getting. Are you in danger of getting sunburned or something? I think this would be a great DEF CON badge where it kind of resets your score if you actually see sunlight, right? So. Okay, and here's another thing, super cool. This is a little lidar, right? This is doing time of flight, and remember, like a nanosecond is 18 inches, and this is accurate down to millimeters, like 10 millimeters. Apparently, the range of this is something like it's from the data sheet. It's 15 centimeters. SparkFun says they get it out to 25 centimeters. But the fact that you can do this on this tiny little thing, it's like 4 by 8 millimeters, is just amazing. So if you want to put a distance sensor on your badge, you got lasers. You got frickin' lasers on your badge, right? That'd be great. Speaking of fricking lasers, this is also stuff I haven't used, but the prices of these things are dramatic. These lidar sensors, some are 1D, some are 2Ds. They'll give you depth maps at some amazing frame rate. And the prices of these are just amazing. Some of these used to be $100,000 not too long ago, but there seems to be an arms race to make these cheap and great. And this is great if you're doing autonomous robots, if you're doing simultaneously location and mapping. You need one of these. Not something I know much about, but I think the prices of these are just amazing. All right, one final couple of optical things is this optical gesture sensor. Once again, it's this tiny little package, just a couple square millimeters, and this has basically a camera in it, and it can detect little wave gestures. You don't need a microcontroller or anything, it's just right there. So once again, something for your badge life thing. You can detect like Jedi mind tricks and things like that, or put this in a beer dispensing robot, or say, give me some beer. Let me see. One final thing to talk about in the optical thing, just because it's so cool, it's this lighthouse thing. This was designed by Alan Yates, who's on Twitter. He is some kind of mad genius of the electrical arts. And the way this thing works is super cool. So it's got a synchronization beacon, and those are those rows of LEDs, and then it's got 2 rotating beacons. And what you do is you see the flash from the synchronization beacon, and then you see how much time elapses until you see one of the rotating beacons, which are directional, and that gives you the angle that you are to this thing, and then you get the other beacon, which gives you the other angle, so you have elevation and azimuth or something. With 2 of these lighthouses, you do some trigonometry, you know where you are in 3D space. And if you have 2 of these sensors, you have 6 degrees of freedom, because you know which direction you're pointing, because you have the 2 ends of a rod or something like that. So you don't even have to buy a Vive or something to get this, because people have reverse engineered or made sensors for this. Trammell Hudson, who I think hangs out at NYC Resistor, yay hackerspaces, has the circuit right here, and Triad Semiconductor sells this chip which does a lot of the hard work of the decoding for you. You still need to do some math and stuff to figure this out, but this is something you can homebrew, which is kind of amazing because this is a really neat system. It does some great resolution at some really high frame rate, like 60 hertz or something like that. Kind of amazing. All right, going to direct the fire hose in a little bit of a different direction, getting away from optical stuff. How are we doing on time? Doing pretty good. All right. Not everything has to be so complicated like that sensor. Save room in your designs for the humble switch, which almost always works. You just close a switch and you can detect that with a microcontroller. You don't need some fancy RFID or face detection if you want to only operate a dangerous machine when you're standing in a safe place. Put a floor switch that only activates when you stand on it, or if you're doing interactive art or something like that. Do not let the super complicated be the enemy of the cheap and easy, which quite often are switches. Also cheap and easy are resistive sensors. You can use these for position sensors. You turn that knob, the resistance changes. You can make a resistor divider and change that into voltage, which you can easily pick up with an Arduino and an ADC. You can get a slider. This is how a hobby servo knows what direction the actuator is. It's got a tiny little potentiometer in there. That's number 3 on that bottom image. And these are fun to hack. You can take them apart, and the little feedback thing, which moves the motor until that pot gives you the right number. You can do things. If you wanted a linear actuator, you could take apart a hobby servo, make it drive, say, a lead screw, put the lead screw on that linear slider on the top right, and the feedback would still work. It would drive the motor until it sees the right voltage from that slider, which puts it in a particular place. So these are fun to hack. I completely recommend taking apart, because they're cheap, just to see how they work. Soft sensors in fabric, anything that conducts basically is a potential switch. And Adafruit sells a conductive thread. You can sew that into your fingertips of your gloves. You can use the iPhone when it's cold out, or you can put sensors on your sleeve and make a piano. Somebody was selling drum pants. Adafruit also sells touch resistive fabric. The harder you push on this fabric, it decreases the resistance, and you can use that for buttons and switches and sliders and dials and things. Super fun. This is one of my favorite sensors because it's free, right? It costs almost nothing. Basically, this is a capacitive sensor which just detects the capacitance of your body by touching a conductor, which can be as simple as a wire soldered to a microcontroller. Most microcontrollers come with a library that do capacitive sensing. Look at Mitch Altman's cool ArduTouch. He's got a little keyboard there that's pure capacitive sensing. You don't need any extra equipment or sensors and anything, just a conductive pad. There are some chips that are designed to do exactly this. Seed Studio has a breakout for one of them. Super easy, and my favorite price, which is close to free. Didn't quite know where to put this one, so I just stuck it in the middle here. This is ultrasonic ranging here. This is super common. You basically bounce a sound wave, an ultrasonic sound wave off an obstacle, and the reflection, the time it takes to bounce back at you tells you how far away it is. And there's a bunch of these out there. They're not expensive. There's the imported ones you've seen on the left. I've used this thing done by Maxbotics, which seem to be a little bit better. It's got a lot of the calculations built into the actual sensor, so it gives you a distance readout as an analog voltage, and it also has this nice thing called a sync pulse. So if you imagine having more than one of these, you can have a problem where the receiver picks up pings from that another transmitter transmitted, and so it gets a little confused. So what you do is you just make them ping all at the same time, and the first one that comes back is the one you sense. So the Maxbotics things have a sync input. You can just hit them with a GPIO, send them all at the same time. Now getting into weird RF stuff, which is super cool, especially I don't know that much about it, so it still seems a little bit like magic. On the left here, there's a good Hackaday article about this. They're very inexpensive microwave sensors, and these are the sensors that they have in supermarket doors. So you just walk up to it and it senses the motion, probably doing some kind of Doppler or radar or something like that, and it just opens the supermarket door. On the right is a radar you can build yourself out of coffee cans, and this still seems like magic, even though this was kind of World War II vintage technology. You have a little oscillator, and you send it out, and you amplify the reflection and mix it back, and you can get the phase difference, which is the time delay, which tells you how far away whatever it was that reflected that radio signal is. Here is something called SOLI, which is a millimeter wave radar thing. I haven't used this. I'm not even sure how real this is, but I like their gifts, so I stole it for this. Once again, fair use. And there's also, if you actually need to detect hand gestures, there's this thing called leap motion, which works really well. It just plugs in over the USB, and it kind of models your hand, as I understand, so you can get a good idea of where your fingers are. Okay, something that seems a little bit more real than SOLI is this thing called Wallabot, which really exists. I know because I bought one, and look at this thing. It's got like those 3 dipole antennas there, and it's got that curved thing up in the upper left is some kind of a transmission line on the PCB. Super RF wizardry, and this can do a lot of things. They sell it for stud finding. I'm not sure that's the right solution, problem that this is a solution for. In fact, I'm not sure what problem this is a solution for, but it's pretty cool. Once again, I got one of this because I'm using it with an art project with a friend of mine. He's going to make artificial organs that I hope are going to, this thing can detect when you are inhaling and exhaling. I want to make the artificial lungs breathe in sync with your actual breath, which is going to be cool and creepy if I can make it work. Okay, flex and force. So you've probably seen these. These are kind of soft circuits. They're printed on Kapton or something using some silkscreen conductive ink that changes conductivity when you bend it or you squeeze it or something. These are great. These are cheap. They're not particularly accurate, but they're kind of useful. I think these were in the cyber gloves. This is a project I did with a friend of mine. Cal, we needed a cyber glove to control this crazy robot thing that you wear on your back. It's kind of a metaphor for addiction. Couldn't find a cyber glove, so we just glued some of these flex sensors to some welding gloves, and that was good enough for the purposes of this kind of punk rock art. If you really want to measure force and deflection, the way to do it is this thing using a strain gauge, and this is, you can get these that you can just slap onto things. The actual signal conditioning for this is a little tricky because they are very linear, but the actual change in resistance when you flex them is very small. You put them in a bridge configuration, which gives you a very small voltage difference, so you need a differential amplifier. In the old days, the Omega or some industrial equipment would happily sell you for $600 a bridge conditioner, like on the bottom right. But these days you can buy them far less expensively. SparkFun has a breakout of this thing called the HX711, which is a bridge amplifier. You put the very small signal in and it amplifies it differentially. And you can buy these load cells for just a couple bucks. This is what's in your bathroom scale. They're pretty accurate. They're pretty linear. They're pretty good. I think always thought it would be fun to get get some sort of a floor tile and put one on every corner, and then it could tell which direction you're leaning on or something, and use that as some kind of an input for something. Moving on, piezo and vibration. How many people have seen the little piezo discs like on the top right? Yeah, right. These are super cheap. They're less than $1. They're probably only a couple cents if you buy them in bulk. A dirty secret is you can plug that directly into an Arduino input, and when you hit the thing like with a drumstick, you can sense that with the Arduino. So you can turn anything into a drum kit just by pasting enough of these things on them and using a MIDI library on your Arduino. I would put a protection diode in there, but don't let that stop you. So the principle of this thing is just this quartz quartz crystal, you squeeze the quartz, it misaligns the crystal boundaries and you get a voltage off it, which you can detect. Not much current, but you get a voltage. And on the bottom right is a vibration sensor using something similar. It's got a little weight that's kind of resonant. If you detect vibration, that vibrates in resonance and it bends the piezoelectric substrate there, which you can then pick up. Let's go to pressure sensors. So I learned all about this doing this surgical robot where we were very interested in measuring the pressure because it's high pressure that removes the tissue. We want to make sure we're at the pressure we think we are. So there's basically 3 flavors of pressure sensors. There's the absolute, where you have a sealed chamber, and they all work by having some kind of diagram which deforms when it's got a pressure differential. With the absolute, it's either a vacuum or some reference pressure. The gauge, the reference pressure is the atmosphere, so this measures the pressure difference with the atmosphere. That's useful if you're doing something like you want to measure how much pressure your fan system is putting on your server farm or something. You want to measure the difference from atmospheric. And finally, differential, where basically you have two input ports and you measure the pressure difference between them. So there's a whole bunch of these things. There's a bunch of MEMS ones where the diaphragm is made of micro machined silicone, and those are tiny. And then there's all kinds of other ones. Here's the MEMS pressure sensor, and SparkFun has a breakout of this. This is tiny. Some of these things are so accurate they can measure the difference in pressure of like a 10-inch distance up and down. And to do that, you basically also have to measure the temperature. So most of these high precision MEMS pressure sensor give you a temperature measurement for free, and that's kind of nice to have sometimes. Here's another kind of pressure sensor, which is a microphone. And this is a MEMS microphone. There's probably one in your phone right now. These are tiny. These are so small that the resonant frequencies are higher than any audio frequency, so they tend to be amazingly flat frequency response. So these are great microphones. I hope somebody in the audio world makes some things of this. I think Seed Studio has a kit with a bunch of them around a circle, and so you can do beam forming. You can make these directional by combining the microphone signals in the right way. So flow, there are a whole bunch of ways of measuring liquid flow, measuring gas flow. If you think you understand the Coriolis effect, check out the Coriolis mass flow meter. I won't get into it, but it's super cool physics going on in that. You can put a little turbine in the flow. An easy way is diagrammed in the top there, where basically you just have a pipe and you put some kind of constriction in that pipe and you put a differential pressure sensor across the 2 sections, and the higher the flow, the higher the difference of the flow. So it's exactly Ohm's law. Basically, you have some current, you have some resistance, and you get some voltage differential from that. Hall effect, this is a cool side effect of the charge carriers and semiconductors. You put a semiconductor in a magnetic field, and the charge carriers, they drift. They will move in the direction of the magnetic field from Lorentz force laws. I don't remember physics, right-hand rule, all that. But these are super great. They will detect a magnet. So if you want to have your magic box turn on something, when you open it, you just glue a magnet to the lid and you use one of these Hall effect sensors. I think this is an Allegro one, the A3144. And that's super easy, and it just gives you a digital output. It goes right into an Arduino or something. You can also use it to detect rotation. You can use it to detect gear teeth coming by. The thing on the left is kind of how a Hammond organ works. You basically have these tone wheels and a guitar pickup. As the wheels turn, they change the magnetic reluctivity, and so you can see when each tooth goes by the sensor. You can also detect angle, and this is nice because sometimes you don't want to bolt something to the shaft of whatever's moving. You can do this kind of non-contact. You just put this at the end or outside the wheel that you want to turn, and this is great because it doesn't even have to be perfectly aligned. You can also detect current. This is great for a number of things. If you want to do a really cheap robotic system and you don't want a limit switch, sometimes you just run it into a hard stop and you look at the current. When that current's too high, you've hit the hard stop. Boom, easy. So talk a little bit about accelerometers and gyros. Anybody played with this? These are super fun. Lots of breakouts. There's many different flavors. They come in different force ranges and things like that. One thing I'd like to draw your attention to is how cool they are inside. And they're so tiny you never see these, but these are tiny little micro machines. And the one on the photomicrograph on the left is a accelerometer. This is a 2-axis thing. You can see the little springs, and this is a plate that moves from side to side. And the one on the right is a gyroscope. That's part of a disc which rotates. Basically, it's being stimulated to rotate in a torsional oscillation, and you can see the interdigitated electrodes which will cause that to rotate using an electric field, and then you can pick up where it is using capacitive sensing. If you want to play with one of these accelerometers, you can get a wee nunchuck for not much money, and there are instructions online how to hook this up straight to an Arduino, and you can wave things around and make lightsabers and stuff like that. Super easy. And if you want to put everything together, if you're doing navigation or robots or a drone or something like that, there's something called an IMU, which is inertial measurement unit, and this particular one has a gyro, tells you which direction you're pointing, an accelerometer tells you how fast you're going, or the accelerations, a 3D magnetometer, which is basically a compass, tells you what direction you're pointing in respect to the Earth's magnetic field, and it's got a 2D inclinometer, which tells you your tilt and things like that. And then it puts it all together for you, because otherwise it's complicated. You have to use Kalman filters and stuff like that. This thing does it for you. Super cool. Fire hose, slightly different direction. Gas sensors. Okay, turns out you might have seen these sensors that can detect basically any kind of combustible gas, any kind of gas that reacts with oxygen. The way it does that is some surface chemistry of tin dioxide. You hit it with a heater, and it changes the resistance, and you can use that to figure out how much of a particular gas is in the concentration. These can be very sensitive. This is the same thing used in very expensive gas detectors, but those have been very expensively calibrated and tweaked and things like this. If you just buy something like this, if you buy something like this from Seed Studio, this is $10 or something. It needs a little bit more work to be accurate, but you can detect things like volatile organic compounds. I don't think it's going to be possible to do a breathalyzer badge, but if you figure out how to do it, I would like to know. All right. Final couple gas sensors. These are humidity sensors, and these are just capacitors with some kind of dielectric that swells and shrinks with the relative humidity. There's a really nice project I liked here. This is a wearable badge with a humidity sensor on it, and also buttons. You can when you press it, you can say this is comfortable, this is too cold, this is too hot, and apparently this all goes back to some smart control that will hopefully adjust the AC so that people are comfortable, and this turns out to be a big deal. Apparently, the thermostats in a lot of places are set for big men who may be comfortable at lower temperatures than smaller people and women. So I like to think about this as some kind of equalizing feedback to get these to get it comfortable for everybody. All right, last couple slides here, going pretty fast. You want to measure temperature. There's a number of ways to do it. A pretty classic one is this thermocouple, where you just have two different metals and you put them together, you get a slight voltage, which depends on temperature. One thing I'd like to draw your attention to are these industrial temperature controllers, which are kind of amazingly inexpensive. This one is like $30, and this is what they use in factories for process control. You need to keep something at a certain temperature. This has a thermometer this thermocouple that's in the bottom there, and it's got this controller which tells you what the temperature is and also a set temperature. You set it to a temperature, and this thing also gives you a relay which will turn things on and off, like coolers or ovens or something like this. So you don't even need a microcontroller. It does all the feedback for you. It figures out the response characteristics of your system. If you've got the world's junkiest toaster oven, you can put one of these on your toaster oven and make the world's best toaster oven. Some of the more expensive ones have serial input output. You can log this stuff. If you want to make your own reflow oven for surface mount soldering or your own hot plate, you can do that kind of surprisingly inexpensively and with surprisingly good temperature characteristics. There are also thermistors. You put these in the battery pack when you take apart your lithium battery. There's probably one in there as a thermal sensor. If you overcharge your batteries, they're going to blow up. You don't want to do that. Super cheap, super easy. There's also this thing called a Dallas Semiconductor 18S20, which has a digital output. You don't even have to worry about any analog noise or anything. There's a couple libraries for the Arduino. It hooks up right to the Arduino. You can put a couple of them in series. They put these things in motherboards and server farms to detect over temperature or under temperature conditions around different parts of the system, but you can use them for whatever you want to. You want a digital thermometer for any reason at all. This one's kind of interesting. I think they discontinued this. This is a non-contact infrared temperature sensing device. I think they finally discontinued this because no one could figure out how to calibrate it accurately. But basically, this uses middle infrared waves and it gives you non-contact temperature measurement. I guess the idea was this: you put it in the casing of your smartphone, and when your smartphone is getting too hot, then you throttle down the computation or your transmission stuff. Kind of finishing up with this thing called a thermopile, and this also used mid-range as infrared, and you've seen these in all the motion sensors, and Tom Cruise has to move really slowly so it doesn't pick him up when he's heisting the jewels or something like that. These work kind of interesting. These need that weird kind of plastic lens, which is high density polyethylene. It works as a lens to kind of separate the field of view of this thing, because this thing works on changes. So as you cross the field of view, it basically has at least two sensors. Sometimes there are four of them in a quadrant. As you cross the field of view, you get this characteristic high beam, low beam thing, which you can detect motion without any kind of outward sensor. This is just picking up the heat. And this is my last slide. This is an interesting use of the infrared sensors, because if you look at the sky is cold in infrared and the Earth is warm in infrared, and so you can use this in a feedback loop to keep your drone stable by trying to keep not too much sky and not too much Earth. So if you keep it right on the horizon, then you know your level, or at least compared to the horizon. All right, so I am kind of running out of slides, running out of time. Got time for some questions and a bunch of resources. All these slides are on my blog. Any questions? Thank you. All right, it's been a long conference. Thanks for making it through.
All right.
Do you have any favorite input multiplexers? You have lots of sensors, but I want to use them all at once.
Yeah, well, it depends what kind of sensor. I think there is a chip which you can hook up multiple I2C to, and I think Adafruit's got a breakout. I forget the name of it, but you can, if you have like a bunch of those, any I2C has a particular address. If you need to hook up more than one, you can put it on this multiplexer chip. And I'm sorry, I'm just forgetting the name of the chip, but I think that's got an 8-way breakout. You just hit it at its address with the address of the one you talk to, and then you can talk to any one of the 8 on the same address that are just hanging off the other end of that. Does that answer the question? Or?
Yeah, and for analog stuff?
Analog stuff, there's these CMOS switches. They have like 16 input or 16 output, 1 input. Those work pretty well. Once again, I'm sorry I forget the actual part number of that, but look for CMOS analog switch. That's a good way to multiplex analog signals, and most microcontrollers will have quite a few analog inputs to using the same kind of mechanism. They just have a little multiplexer on the input.
Thanks.
Sure.
Howdy, quick question. So you showed a hardware PID controller. Do you have any favorite software PID libraries?
You know what? I don't. I'm old school enough that the last time I did that, I wrote it myself, which was probably a mistake. If you know of any great ones, I'd love to hear about it. And then just generally, if I've forgotten your favorite sensor, let me know about it. I collect these things, and I don't want to miss anything cool. So thank you.
Thank you.
Sure.
Yeah, those Dallas semiconductor temperature sensors are great. I have like dozens of them scattered around the house. Especially interesting instrument like the HVAC, and look at the delta T through the system. I did find out one interesting aspect of them, though, is there's specs for what the maximum temperature is, but not actually what temperature gradient they'll handle. So I had one on the Freon loop in and out of the exchanger, and I had like 3 of them fail coincidentally, and I think just the rapid temperature change when it became really cold really fast ended up fracturing something.
All right, that sounds right. Yeah, so how cold was that, just out of curiosity?
It wasn't particularly cold, it just went from...
Right, it cycled, yeah.
Yeah.
So you get thermal cycling, the epoxy cracks, yeah. Good times.
Hi, how you doing? First, thanks for coming.
Thank you.
Really appreciate the talk. I have a question about a sensor that you mentioned briefly, the microwave sensors.
Yes, sir.
Have you seen them in practice much using detection of objects like in public places, like airports or transit areas, just to have an idea of what someone might have on them?
No, I haven't. I'm not sure. At least the Wallabot I played with, I'm not sure it's. I would not use that for mission critical detection, because it looks like a work in progress. But I'm sure there might be stuff out there that's considerably more sophisticated. I don't know about it. If anybody does.
I've seen some of it online. I just don't have any details.
All right. Yeah.
Thanks.
Sure. Thank you.
Yeah, hi. We do mentoring with junior high kids, and they bring the little brothers and sisters along.
Great.
I like to just throw everything out at them and let them play around with it. But do you have any recommendations if you just hit the web and look around for educational?
Yeah, you know what? A great thing to start with is Mitch Altman has some wonderful little kits. There's a little retroreflector thing. You wave your hand over it and the color changes. It's like magic. It's great. And it's small, and it's a great starter soldering kit. Find Mitch if he... Yep, all right. That's a perfect thing. That's Mitch. Yeah. He's got some great educational stuff, and he's got a lot of experience with the younger set. So he's a great resource for that. All right, I think ending a little bit early, probably not a bad thing. It's been a long conference. Thanks for coming out. Thank you, everybody.